Hello everyone, how are you all? Very good evening. So we are about to start in a minute. Let us have some few more students, then we would be good to go. Okay. Circular link list. Okay. So now I hope you all can see the screen, and I'm just sharing the code. So this was the code, and this is the whiteboard where I will explain the things. So we have done till how we can delete the first matching element from a single circular linked list. So you can see more or less all the operations are almost similar. So now I'm not going to show you the diagrammatic explanation. If you have a doubt, then tell me, then I will show you the diagrammatic explanation. So this, it was done till here. Now we are going to start from delete at a particular index. Now what does this mean? So the index will start from 0 and we have to delete at a particular index. So our code is accepting a position and we have to delete if a node is present at that index, we have to delete that node. So let me okay, so this will be fine because if head is null, we can return simply. Now two things can happen. Let me just erase these things. Now if the position is 0, suppose, okay, so if this position is 0 and and there is only single element in the linked list, so how we can check that? So if the head is equal to tail, so in this situation what we can do, what does this mean? It means that we have only single element in the linked list. So how we can delete that single element? So and the position is also matching with 0, means we have to delete that index only. So that's why I am checking with 0. So we can simply do head is equal to null as well as the tail is equal to null. So I'm just doing head is equal to tail is equal to null. Now this is done and simply I can return. Now next, what condition may occur? Suppose we have a linked list of whose we have to delete the zeroth position. Okay, we means the first position, but it is not having only one element. It is having more than multiple elements, but we want to delete the first index. So if this condition is true, control will not reach this part. Okay, not only if the linked list is having more than one element and we want to delete the first index, then only it will reach that position is equal to 0. Okay, I should explain your diagram. Alright, I will explain. Just let me write the code. Now if the position is 0, what we can do? We can do head is equal to head dot next. So this is the normal thing which we use to delete a node. So see, if the position is 0 and head is equal to tail, what does this mean? It means that head is pointing to the one node and tail is also pointing to that node only. And this is a circular linked list, so this is pointing to itself. Now we have to delete element at 0th position. So simply can't we do head is equal to null as well as tail is equal to null. Okay, so this was the situation. You can see at line number 130. Now if the position is 0, what does this mean? It means you have a linked list which have more than one element, and this is pointing to the first node and there it is having tail. Now we want to delete the element at position 0. Now what we can do? We can do head is equal to head dot next. So this link will be broken and will go to the next node, and we can do tail dot next is equal to head, means we can change this reference and we can change it to the new head when the new head is pointing. You see the new head is pointing to this node, so this is pointing here. Okay, so these two statements we can do. So that's why I have done head is equal to head dot next. Next I'm going to do that tail dot next is equal to head. So this is the new first element and simply I can do return. Otherwise we will use that iteration method only to search that to reach to that particular index. So for that I am keeping one node reference as previous. I am calling it as previous. So we have already seen this for deleting. So see, we have already done the code for deleting the first node. So what I am going to do, I am going to start previous from head and I am going to start temp. Let us call it temp only. Temp from head dot next only. Now we are searching that if this temp is equal to that position, means the position which we need. So see, we are starting from this node. Okay, this is temp and this is the previous of temp. This is the previous of temp, and in every step we will take a variable count. Okay, and we will start the count from 1 by 1 because 0 we have already because we are starting from the index 1. Okay, this is the index 1. Okay, so that's why we will start from count, and in every step we will increment the count and we will move the previous to the next node and the temp to the next node until our count matches with that particular position. So that's why I'm taking previous is equal to head, and I'm taking one more temp is equal to nothing but head dot next. So this is done here. Now we are also taking the count variable which I just now told. So I'm taking count is equal to 1 and I'm running a loop. Okay, I'm running a loop until this temp is not equal to, now see, temp is not equal to what I can take here. So I want to include the last node also. So when this, okay, just a second. So when this will iterate the linked list, okay, when the temp will iterate the linked list, so suppose this is the linked list. So after the last node, it will all again come to head. So can't I say that temp not equal to head? Okay, so that's how I will include the last node also. So I am taking that temp not equal to head. So previous is equal to head. Let me show you when I will do the while loop, then you will understand why I am taking the previous node. So because you have to eliminate a node in the between, so for that we need two reference, now one for previous, one for the that particular node, so that we can change this reference to the next of the temp. Making sense or not? We have done this already in the single linked list. So, and one more thing we have to check that this count, okay, so let me call it as COUNT. So this count is not equal to the position. Until then we are going to iterate. So how we can iterate? We can simply do previous is equal to temp. So you can see it is moving to the next node, and again temp is moving to the next node by temp dot next, and we are also implementing the count variable with 1. Now suppose we reached at line number 149. Now what are the situations? First situation will be that we have again reached the head. Okay, means we have reached where? We have traversed the whole linked list and we have reached the head again. Now it means what? It means, can't we say that if the, after this iteration, if the head is equal to 10, can't we say that the index is invalid? Yes or no? Because suppose we have an index as 3, we have iterated 0, we have iterated, okay, so it is starting from 1, we have iterated 1, we have iterated 2, again it is going to where? It is going to the head. Now if it is head, now count is also implemented, but doesn't matter. If the head is reached again, it means what? The index is invalid, that index is not present in the linked list. So for that I am checking here that if this temp, okay, if this temp has reached head again, okay, let me write here that this is what this means, invalid index. So in this situation what we can do? We can just return, it means the index is at that index, no node is present. Otherwise what can other situations? The index is found at the tail. So for that what is the condition? So the temp should be equal to tail. So else if we can say that temp is equal to the tail, just a second. So what is the condition? It means what? We are, or the position is at the tail. So we have to eliminate the tail index. So for eliminating the tail, what we can do? So we can simply do the thing which we used to do, previous dot next is equal to temp dot next. And since we have a tail also, so we have to set the new tail. So what will be the new tail? So let me show you diagrammatically so it will be more clear. So this is the head, this is the first node, this is the next node, this is the next node, and this is pointing here, this is the tail. Now if the tail, we have reached the tail, it means what? Temp is pointing to the tail index, tail node, and previous is one before that. Now we have to eliminate this last node. So two things we are going to do, that is previous dot next is equal to temp dot next. So what is temp dot next? Temp is again pointing to head. So this is pointing to head again. Now this link is broken. Now what we have to do? We have to set this tail. So we have to set the tail as what? Previous, because now previous is the last element. So that's why I have written previous dot next is equal to temp dot next, and I am setting the tail. I'm setting the tail as what? I'm setting the tail as previous. This is done. Otherwise, what is the else case? If all these cases fail, what will be the last case? What can I do in the else block? Can you tell me? So otherwise it means what? The element is found in the middle. Okay, if it is not reaching head again, if it is not at tail again, and we have already done the coding part for head, so it means it is in the middle part. So for middle part, what we can do? We can simply do previous dot next is equal to temp dot next. Okay, so that we have done in single linked list also. So I hope that you all know this. So I'm copying this previous dot next is equal to temp dot next, and this is what this is means, that the node or the index is at the middle. Yes. So what's count maximum value? See, the count will maximum reach till the length plus 1. Okay, you can see the length of this. Okay, the index of this last index of this linked list is 2. So it will reach 3. So it will only reach 3 if the element is not found in the entire linked list. That's why I am checking just after the while loop. I am checking that temp is equal to head. Okay, it means what? The index is invalid. So it will start from 1, means the next node after the head, and it will stop until it reaches the head. You can also see here that temp is only going till the head. Okay, it is not equal to head. Now this code is done, so I am removing the beta word from here. So this should be working fine. We'll check all the functions later at once. Now let us do for searching an element. So for searching what I am going to do, again this part is correct. If head is equal to null, we can simply print the element is not found. Otherwise, we can take the temp as head, and I am taking count as 0. Why we are taking count? Because if it is found, we have to print the particular index also. Now, while this temp or this, okay, while this temp is not equal to null and temp dot data not equal to p, we can simply iterate the linked list. Yes, and while iterating, we are also incrementing the count variable. Now, next, what things you have to check? Let me remove this. So their temp will never be null. Why? Because it is the condition in the case of single linked list. Here the temp after last node, it will again go to head. So I am just removing these parts, and let us write the conditions. Now first condition will be that it may reach the last node. Okay, so if this temp is not equal to tail, it means what? It is found at middle. So see, this won't be the exact code. You can create these functions in all different ways. Okay, you can create these functions in many different ways. You can see somewhere I have used while loop, somewhere I have used for loop, somewhere I have done the part for the head first. So these are just for understanding. So in suppose in interviews, they just check your ability that can you implement that function or not. So that ability they check. So what process you are following, that is not important. So this means found at middle. Okay, when the temp is not equal to tail, it means found at middle. So if it is found at middle, what we can say, we can simply print that, because you have to search the element, so we can print that found at index. And what is the index value? It is nothing but stored in count. So this is done. Now next thing what can happen? So I am taking else if. Okay, else if last is, tell me what will be the condition if it is found at tail? What will be the condition if it is found at tail? So one thing is for sure, that this temp, okay, this temp should be equal to tail. Yes or no? Tell me yes or no. Okay guys, be interactive. Yes or no? If I am searching for last node. Okay. Now what next thing we have to check? One more thing we have to check. One more thing we have to check, that if the data is matching or not. So I am checking that last dot data. So just a second. Okay, it's not last, it's temp. So temp dot data. If this data is equal to key, in this situation, it means what? It is found at tail. So I'm writing here so you can understand later that found at tail. Now if it is found at tail, what we can do? We can simply print that. Okay, so we can just print this statement only. So I'm just copying it from here and I'm pasting it after else if. Now otherwise in all other situations, it means what? The element is not found. So I can print and I can eliminate or remove these things and change this to what? That not found. Okay, this is done. Now let me remove beta from this part. So this is the correct code for searching a value in a single circular linkage. Now traversing the list. Now, do we need to change anything in traversing this list? Tell me. So some things we need to change. So what is that thing? So let me add one condition just that if this head is equal to, okay, if I don't add this then also it will work. If this head is equal to null, we can simply return. Okay, so if you have seen Sunil the previous lectures, so you can see all things are relatable. So that's why I'm not drawing the diagram again. Now, if the head is equal to null, we can return. Otherwise, we can iterate the list. So head, I have taken the temp as head because we are starting iteration from the head. And till where we can go? We can go, just a second. So we can eliminate this null and we can go till tail. So this is done. And we can print temp.data. Now, you can see if we are going till tail. Okay, now let me show you using diagrams. So this is the head. This is the first node, this is the next node, this is the next node, and this is the last node. So this is tail. So what this will do, if the head, let me use a different color. So if the head is null, it will return. So now head is not null, head is pointing to a particular node. So it will take temp as head. So this is now my temp. Now it will print temp.data. Suppose it is storing 1, 2, and 3. So 1 will be printed. Now it will do temp is equal to temp.next. So this reference will be changed to this reference. Now it will again check why temp not equal to tail. So yes, temp is not equal to tail because tail is here. So it will print the data again. So 2 will be printed and temp reference will be updated to temp.next, that is this node. Now it will check temp not equal to tail. So no, temp is equal to tail. So what will happen? The while loop will stop and you can see we are having print ln. So only this much will be printed. But we have to also include the last node. We have to also print the tail node. So for that we are doing some what we can say extra thing. So at last when the while loop stops, so we can print the data stored in the last node. Okay, so already the temp is pointing to that node. So what I can do, I can print temp dot data after the while loop has ended. So in that case we will also get the 3 here. So for that, in this print statement only, I am just adding up that a single space plus. So temp is now pointing after the loop ends, temp is not pointing to the last node. So temp dot data. Making sense or not? I hope it is making sense. Okay, so now our code is complete. Let us check the main block if any changes are required. So the name of the class is single circular linked list. So yes, we have already done that. So 1, 2, 3, 4, 5, 6, 7, 8. So insertion. Just let me check. Insert at front, insert at end, insert after element, deleting element, deleting from index, displaying the list, and 7 for searching, 8 for deleting the list. So I am running it and I'm checking if it works or not. Alright. So now it's yes, now it's running. So you can also check later. You can download this code and do that. So 1 is for inserting at front. So I'm entering 22. Again, I'm pressing 1. I'm entering 23. I'm pressing 1 and I'm pressing 24. So you know when it is inserted at front, it will get in a reverse order. So if I press 6, it should display the list. So you can see it is displaying the list 24, 23 and 22. Now if I insert at end, so let us insert 11. Let us insert at end 12 and 13. So now you can see the things will be inserted at the end, that is 11, 12, 13. Next operation is to insert after an element. So let us try to insert after 22. So for that I am pressing 3. Now we have to first enter the element which we want to insert. Let it be 999. And after which we want to insert, so let us insert after 22. So now you can see if I press 6, so after 22 we are having triple line. Now what if the key is not matching? Suppose we are pressing 3 for inserting after element. Our data is, let us take 444, okay, 444. And suppose the data, like we don't have 14 in this linked list, so I am taking 14. Now what would happen? So let us check. So that element is not inserted. You can see 444 is not inserted in the list. Now let us in the same way we can check deleting an element. Okay, so let us see 4. Now if we try to delete 13, so the last element will be deleted, and if I press 6, You can see it is till 12 only. Now how we can delete from an index? So I'm pressing 5. Let us delete the index 0. So I'm pressing 0 and let us press 6. You can see initially what we are having at 0, 24. Now 24 is missing. So let us delete the index 2. So index 2 is what? 999. So I am pressing 5 and I am entering the index 2 and I am pressing 6. You can see 999 is no more in the linked list. Now we have already seen 6 for displaying the list. For searching, let us use 7. So I am pressing 7. Let us search for element 13. So you can see it is not present. So it should say not found. So okay, so some mistake is there in the search part. So let us check for the search part. So where is the code for the search part? Okay, searching element in the linked list. Yes. So here is the mistake. So you can see we have not updated the temp is this temp is equal to null. So what will be here? Can you tell in the searching part? So we can check till tail. So okay, it is not equal to tail. So now just a second. Okay, now I think it should work perfectly. So I am running it again. Let me check the comments. Yeah, you all are very much correct. That what was the mistake. Now again I am doing for searching. So quickly let us insert some values. I am entering 1, I am entering 2, I am entering 3, I am entering 4. So let us print. So it is printing 1, 2, 3, but cool. Now let us search. So for searching I am pressing 7 and I am searching the element. Let us search for 4. So it should print that index 3 because index starts from 0. So yes, found it index 3. Again let us press 7 and let us search for 5. It should say not found. So cool. It is now saying not found. So you can see this is the hit and trial method. You can correct the errors by checking also. Still, if you just found any mistake after the running of this code, just notify me. Okay, I will update that code. I don't think because I have already checked these. Okay, so I don't think there any mistake will be there. So now let us press 7 we have seen. Let us press 8 so it will terminate. So now this code is complete. I will push this code in the GitHub link. Now let us see the complexities. So quickly tell me the complexities. Okay, it is almost similar. Okay, all the linked list. So for creation, what will be the complexity for creation of a single circular linked list? Okay, I'm talking about a circular single linked list. Big O of 1, everyone agrees, and space complexity also big O of 1. What is for insertion? Okay, for inserting a particular node, and remember I am talking in the terms of big O notation. So yes, it will be big O of n. And space complexity will be big O of 1 by why? Because we are taking a constant space. Now you will say, sir, it should be big O of 2. Why big O of 2? Because we are taking two memory locations. First memory location is for the data. Second memory location is for the reference of the next node. But still, if we say that big O of 2, or suppose if it is int, so what is the size of int? BSIL 1, 2, 4. So 4 bytes. So if even we tell that part, so then also you can see it is a constant value. So for constant, even it is big O of 1000, we will consider it as big O of 1 only. So now for searching, you all know that we have to traverse the whole linked list. So it is big O of n, space is big O of 1. So I'm quickly writing it because I know that you all know the answers. So if you have any objection with any complexity, just tell me. Now deletion of a node. So for deletion, in the worst case, we have to iterate. Suppose we are checking for an index or we are checking with a value. If we are matching with a value, in both the situations we have to iterate. And the space complexity is big O of 1. Now deletion of linked list, we are just dereferencing, or if we are not doing that also, that is done by the garbage collector in Java. We are just terminating the program. So it is done in big O of 1 time complexity. Now in some places, okay, in some of the different places where you will study, you will see that deletion of this linked list, okay, not this, the double linked list will be big O of n. Okay, so that I will talk when I will do the double linked list. So let us start with double linked list. So why we need to do system.exit? See, we need to do system.exit because that switch case which we have written, that switch case is inside a while loop which is infinite. Okay, you can see the condition is always true. You can check the code also. Let me just show you where is the coding. Yes, you can see in the main block we have written this whole thing. Yes, inside while is equal to true. So this will run ultimately until we don't forcefully stop this code. Okay, so if the neither of the operations are aware, you can press 8, so the linked list will be destroyed and the code will be terminated. I can also do break here, so break will bring the control outside of the switch block. So now let us discuss the next type of linked list, that is double linked list. So what I am going to do, if the time is less, I will just copy the code because these are just similar to the single linked list. Okay, let us talk about it first. So double linked list means what? Each node consists of 3 things. So if we are declaring a node, so we will create 3 variables. So first will be int data, obviously you all know. Now next will be node type of the next node. So this you all know from the single linked list. Now new thing is that we are going to have a third reference, that is a reference to the previous node. So this will having the data, this is having the reference of the next node, this is having the reference of the previous node. So this part we are adding. Now they are the data and the 2 different references to the next and previous nodes respectively. So let me show you how it looks. So suppose if we have created one node, so our head will be pointing to that new node. So this is the new node. Now suppose it is having data as 1. Now this is what? Suppose if it is new node, so this is new node dot next. So this is pointing to null. Why? Why null? Because it is a double linked list. It is not a double circular. So when you go to the circular, so this will pointing to itself again. And since head is pointing to this, so previous reference will be again pointing to null. Now suppose if we insert elements, so how it will look? So this is head. Suppose if we have 2 nodes, so this is the first node, this is the second node, and let this be null. We have, let us have 2 data, so first is having 1, second is having 2. Now the first node next is pointing to the second node previous is pointing to the first node. So this is the situation. In the same way, first node previous is pointing to null because we have no elements before that, and second node next is pointing to null. Now in the same situation, you can now imagine that what will happen in the case of 3 nodes. So if we add more nodes, so don't worry, we are going to code that part. So now you have understood what is the pattern. First we will understand it diagrammatically, then we will see the logic, then we will code it. So now tell me what will happen. So this will be pointing to this will be pointing to next node, and this second node dot previous is pointing to the previous node. Again this is pointing to this is pointing to previous. Last node will be pointing to null, first node will previous of the first node will be pointing to null. Now let us have a tail here also. Okay, so yes, I am also creating a tail. So what is the need of the tail? I will tell you. Okay, just now I will tell you. I am also creating this tail. So the operations are creation of a linked list, insertion of node. So again we are going to see all those 2 types of or 3 types of insertion. Traversal. Now in traversal we are going to see 2 traversal techniques. First is the normal traversal. Okay, the normal traversal, and second is the reverse traversal. Why reverse? You can see we are having previous pointers also, so we have to check that it is working or not. So I will create a function with the name as print reverse when we will do traversal. So this will as we used to do from head, we started iterating. In the same way what we will do from tail, we will start iterating, and in every step what we can do in reverse traversal, we will do temp is equal to temp dot prev. Okay, it means previous. So let us code this. Okay, and deletion are same, deletion. Okay, these operations are same. Just one new operation we are going to add, that is reversal. So I am going to the ID. So this is the ID, and I am creating a new class. So let me name the new class as, in the linked list package only, I am creating the new class and its name is double linked list. So what would be better? So which code will support help us to write minimum code? If I copy the code from single linked list, or if I copy the code from single circular linked list? So the most efficient will be that if I copy the codes from single linked list, we just have to add the previous node because the null concept is already present in single linked list. Yes or no? So that's why I am copying it from here. Okay, and we will do the changes. I hope that you are not having any problem with this updating thing. Means if I am copying the code, I am not writing the whole code again, because this will also give an idea that what is the extra thing which we are doing. Okay, No, cool. So now I'm pasting it without formatting, and basic things I'm changing. That is, first the class name I'm updating that to double. So today's class I want to just end all the types of linked list. So I think it may go to 2 hours. Yesterday what happened? The limit was just set to 1 hour 30 minutes, and the class expired because the link was over. Okay, I have to import the util package. So import java dot util dot start. It's done. Just a second, let me check the main block. So here we are going to create the object of the double linked list. I'm writing double, and I'm just also writing it double. Now, okay, so this should be removed. Now making sense. Now one extra operation I'm adding here. You can see 6 is for displaying the list. Displaying the list, I'm adding. I'm copying this 6 and I'm pasting it here, and I'm writing that 7 is for reverse displaying the list. Okay, so this is nothing but reverse traversal. So reverse displaying the list. Just a second. Now again I have to change this 7 to 8, and I have to change this 8 to 9, and here also you can see I have added at 7th number. So I am adding a case 7. So case 7 colon. So we will do the working for this later. Let me have the break also. Now this 7 will become 8, and this 8 will become 9. Now we are good to go. Okay, so at this situation what we are doing? At this situation we are we can call it as creation of double linked list. Now let us don't waste our time. Let us come to the first part. Now what changes we have to do? So you can see we have a head reference. Okay, so first let us add some things here. So we are having next, and we can have previous. So this is done. And when we call the constructor, means when the object is created, we can assign previous is equal to null. Now you know this thing is also not required. If we don't store anything in the references, it is already pointing to null. But we write this thing for just for understanding. Means the new node is created and it is not pointing to anywhere. Now we need a tail reference also. So I am writing that tail reference. Then I am writing node and tail. This is done. Now these are just a beta function. Okay, so insertion at front. Now tell me what will be the changes for inserting an element at front. We have created the new node, and after this new node, if the head is null, means if the linked list is empty. So let me just have the whiteboard also along with. So when we need the explanation, we can check that. So I'm taking a situation if this head is equal to null. In that case, how we can insert element? If this head is equal to null, can you tell? So let me show you. So if this head is equal to null, we have already created a new node, and we have some element. Okay, so we have the data. The previous is pointing to null, the next is pointing to null. So now what we have to do? We have to change that new node dot next is equal to just a second. We are checking double linked list. Head is equal to new node. Okay, so if we are having new node like this, so we can say this is the data. So we can say head is equal to new node. Okay, so head will be pointing to this node, and we also have a tail reference. So since this is the last node only, so we can say tail is also equal to new node. Now is there any need to change next or previous? So since it is not a circular linked list, there is no need to change the next or previous. Cool. So let me do this thing here. So we are if the head is equal to null, we are updating that head is equal to new node as well as the tail is equal to new node, and simply we are returning. Now otherwise what is the situation? It means the linked list is not empty. Now if the linked list is not empty, we can do new node dot next is equal to head, and head is equal to new node. Now one more thing we have to do. Okay, so let me show you. If this is like this, head is pointing to one node, it is pointing to null. So this previous is pointing to somewhere, and this is pointing to null, and this is the tail. Now we have to insert at this position. So let me take the node. So this is our new node. So what we can do, first thing we can do that new node dot next is equal to it, because we want to make this pointing to this. So I am doing new node dot next is equal to head. Next what I am doing head dot previous is equal to new node. So you can see this was our head is pointing to this, so head is this. Now head dot previous is equal to new node, and lastly we can update head is equal to what? Head is equal to new node. So I am writing here, so you can understand head dot previous is equal to new node, and head should be pointing to the new node which we have just inserted. So you can see we have already two statements written here, that is new node dot next is equal to head and head. Okay, so you have to add that head dot previous is equal to new node. So you can see just one thing we have to add, and head is pointing to new node. So this is done. So with this we have completed the insertion at front. Let us change the other functions also. So insertion at end. Now for inserting at end we have created a new node. Now if the head is equal to null, now what we can do? Can we just copy these things? Let me copy it from here. So can't we just copy this and paste it here in the situation when head is equal to null? Just a second, let me check one thing. If this head is null, this head is null, so we are doing head is equal to new node, tail is equal to new node. Okay, so this is correct, I think. Now we are returning. So yes, this part is there is no confusion in this part, yes or no? Because we have just discussed this here only. If head is null, we can make both the references pointing to that particular node. Now otherwise what we can do, we can now there is no need of iterating. You can see since we have the tail reference, so we can directly insert at end. So I am just removing these things. Okay, so I am just removing these things and using a diagram. Let me explain you what is insertion at end. So head is pointing to a node, so this is like this, and we have this is pointing to null, tail is pointing to that node, this is pointing to null again. Now we have to insert at end. So for inserting at end, suppose this is the new node, what we have to do? So we have to change tail dot next is equal to new node. So this will be pointing to here. So I am writing here tail dot next is equal to new node. Now what next we have to do? So we have to change this previous is equal to tail. So new node dot previous is equal to tail. Now what next we have to do? So see, you can see this is the new tail. Okay, so this is the new tail. So yes, here you are absolutely correct. This is the new tail. So what I am going to do? I am going to change tail is equal to new node. Any more thing required? So no, we have all successfully inserted at end. So let me write it here, insertion at end, that tail dot next is equal to new node. Next I am adding that new node dot previous is equal to nothing but tail, and lastly I am updating tail to what? Tail I am updating with new node. So this is also done. You can see the insertion is correct. Let me check. Okay, so now let us see inserting after a value. Now for inserting after a value, if this head is equal to null, we can return. So this is fine. Now inserting after a value. Now there is a need of iterating. Okay, we cannot do without iterating, because if it is found in the middle, so the tail cannot help us. So again we are taking A as head and B as head dot next. Okay, so these things I have already discussed in the single linked list. If you don't understand, just tell me. Now if this A is not equal to null, why A is not equal to null? So A will be only null if we reach the last element. You can see, because the tail will be pointing to null. Yes or no? Tail will be not pointing to the first node, because it is not a circular linked list. And we are also checking if the A dot data is not equal to key, because we have to insert after that key. Now if this B is equal to null, we can return. Otherwise we can update both A and B to the next node. Now after this while loop, what it does mean? It means that we have successfully reached we have reached our correct position. So what we can do? We can do a dot next is equal to new node. So let me explain it using diagram. So it will be helpful. Suppose this is head, this is the first node, this is the second node, this is the null. Okay, I'm just taking two nodes. You can have multiple nodes also. So this is pointing to here, this is pointing to here, this is pointing to null, and this is pointing to null. So we have to insert after. It means what? This is A, this is B. We have to insert after A. So now suppose we have created the new node. Okay, you can see in the first line only we have created the new node. Suppose this is storing 1, this is storing 2, this is storing 10. So initially this is pointing to null, this is pointing to null. Now what are the connections which we have to make? So we have to make that a dot next is equal to new node. So you have to break this reference and say that a dot next is equal to new node. And okay, I will be slowing a bit. So see, these operations are almost similar. That's why I am just speeding up. So we can complete it today. When we will study stack, then I will keep the speed a bit low. Okay, so these are almost similar. You can see. Now we have to change the previous of this node to the A. So this is A. So new node dot previous is equal to A. So let me write it so we can directly code them later. So A dot next is equal to new node. Then what we can have? New node dot next, new node dot previous. We are updating this previous. So new node dot previous is equal to A, and new node. Now you can see we have to update this next also. So new node dot next is equal to B. So new node dot next is equal to B. Now more situations is here. Okay, so let me write this thing. One thing is left, that we have to update B dot previous is equal to new node. So why I'm not writing that, I will tell you. So new node dot next is equal to, I'm writing including here that new node dot previous is equal to A. Now situations can happen like, suppose if this B is not equal to null. Okay, suppose if this B is not equal to null, means if it is the last element. So what we can do? So we can simply do that B dot previous is equal to new node. So I'm writing here, if this B is not equal to null, I can do what? I can do B dot previous is equal to new node. But suppose if it is null. Okay, so in that case, our A is the last element. Okay, means if this A, just a second, if this A is equal to tail, it means the B is null. Okay, if the B is null, then only A is the tail. So in this situation, we can update tail to what? We can update tail to the new node, because it is the ultimately the last node. So making sense or not this part? I hope it is making sense. Okay, everyone, seems that my explanation is too fast. Okay, now I will try to slow a bit. So we are going to the next operation, that is deleting the first matching element. So now we have to do a longer thing. So first we are taking temp as head and previous as null, as we done in the single linked list. Then we are searching if temp not equal. Okay, so if head not equal to null and head dot data not equal to key. Okay, so we are searching that if this head is not null, okay, and the data is found at the first node only. So what we can do? So still we have more operations. So I am just writing it here. Now if the data is present at the first node and we have only single node, okay, so it means what? Head is equal to tail. So in this situation, what we can do? We can just update that tail is equal to head dot next. Yes or no? Tail is equal to head dot. I will draw the diagram for this. Head dot next. So we are deleting the first. So suppose if the head is not equal to null, head is pointing to a particular node, and this is pointing to null, then the tail is pointing to this node, this is pointing to null. Let me check the comments. Okay. Now if the head is equal to tail, means if we are having only one single node, so we can do we can update this tail as head dot next. Yes or no? So head will be pointing to the null and tail will be also pointing to the null. So for that, I am just writing one more thing, that tail is equal to head dot next as well as head is equal to head dot next. So this, why I am doing this, we are having single node, then only we are going to change the tail. Otherwise, we will just do head is equal to head dot next as well as if the head is not equal to null, take this head. So we already know that head is not equal to null. So we can change that head dot previous is equal to null. So this is how we will delete and we can return. Now next, otherwise we will use the while loop to iterate and find the first matching element. For that I am taking temp is equal to null, and until this data is not matching with the key, we are updating previous is equal to temp and temp is equal to temp dot next. You can see in all these cases we are using normal traversing only. Okay, so for reverse traversing we will create a function so you all can understand. Now if this temp is equal to null, we can return simply, because it means what, the data is not found. Otherwise we can do previous dot next is equal to temp dot next. Okay, if it is found in the middle. Now just a second. Let me this is the second one. This is the just a second guys, let me check if I am not going wrong. And lastly this is pointing to null as usual. This is the tail, this is also pointing to null. Now if the temp is equal to null, we can return, means the data is not found, that is clear. Otherwise we can do previous dot next is equal to temp dot next. So suppose this is temp and this is previous, so we can do previous dot next. Okay, previous dot next is equal to temp dot next, means we are pointing to null. So that we are doing. Now if this temp is okay, temp dot next. Okay, so if this temp dot next is not null, suppose we have more elements, if we have more nodes there, so we have to break this reverse link also. Okay, we have to break this reverse link also. For that I am checking that if this temp, means if this temp dot next, okay, so if this temp dot next is not equal to null, okay, the temp dot next is not equal to null, I have to break the reverse link. So for that what I can do, I can go to temp dot next dot previous, yes or no, and what I can make this, I can change it to previous. Why previous? Because you can see this link I am breaking, okay, this link I am breaking and making it to come here, so we can eliminate this element. So that's why I am checking, we are checking first that temp dot next not equal to null. Okay, otherwise we do normally. So in situations where temp dot next is null, it will show a null pointer exception. That's why I am checking this if condition. Now one more condition I think we can include. Yes, if it is present at the last node, we have to update tail also. So if this temp is equal to null, tail. So if this temp is equal to the tail, so we have to update the tail also. So we can do tail is equal to what? So you can see tail is equal to previous. Why? Because previous is the last node. We have just deleted the last node. So previous is the new last node. Okay. So I hope it is making sense now. Now let us move to how we can delete element at a particular index. So for deleting element at a particular index, we need the position. So yes, we are having the position. Now if the head is null, we can return. So yes, we can return. Now if this position is 0, so I will copy this part. Just a second. Okay, so I am copying this part. Why? Because if we are deleting the first matching element, now if the element is found at the head only, so that is the situation if the position is 0 also. So that's why I am copying this here. So this will be almost similar. Now we are taking temp is equal to head, and I will use a for loop only. Okay, since we have used for loop earlier, So you can see we have to reach at a particular position, but we are going -1. So later we can update that using this statement that temp.next is equal to temp.next.next. So while iterating, we will reach the node which we one node previous to that particular index. Now we can check if this temp is equal to null or temp.next is equal to null. We can simply return. Otherwise, what we can do? We can do temp.next is equal to temp.next.next. What does this mean? So this mean I hope you all know this thing. So this is head, this is one node, this is one node, this is one node, and this is pointing to null. Suppose if the temp is this one is temp, okay, this is found. So no, we have covered head in the if situation only. Suppose if this is temp, so what we can do? We can change temp.next is equal to the next of where temp.next is pointing this is temp.next. Okay, this is temp.next. So we are going to temp.next.next, that is to null, or otherwise if we have nodes here also, so it would be pointing to that node. Now if this is not null, suppose if this is not null, you have to change the previous reference also. Okay, so we have to change the previous reference also. So what I'm going to do, I'm just adding a statement that if this temp dot next, so let us do if it is equal to null. If it is equal to null, it means what? That temp is the last node. Yes or no? If it is equal to null, it means temp is the last node. So we can update the tail as what? We can update the tail as temp. Okay, this is making sense, I hope. Otherwise, what we can do? We can do temp dot next dot previous. Just now we have discussed this. We have to change the previous node and it should be pointing to temp. This is how we can eliminate this particular node from here. So this is how we can delete at a particular index. Okay, so if you will go to the code again, or if you will go to this recordings again. So okay, if you will go to the code again, if you found any problem, you can go to the recordings again. I hope that it will be very much clear if you just observe the code once after the class. So now let us go for searching part. You can see just with few changes because changes are because of the previous nodes. So by adding few changes, we are obtaining the double linked list functions. Now for searching an element, now do I need to change this code? Tell me. Is there any need to change this code for searching an element? If no, tell me why. If your answer is no, tell me why. See, just check this code. Is there any need to change this code? No. Now, why the answer is no? You can see the double linked list is having a single linked list in itself. Yes or no? If we don't consider the previous nodes, so we can simply do it as we used to do it in a single linked list. We can iterate from front to back, and we can match the elements. If the key is matching with any of the node, we can say that found at index, and we are using the count variable normally, which we did in the single linked list, and we can increment along traversing. You can see along traversing we are incrementing the count. So this we have already discussed. So for saving time, I'm not discussing this. You can see the head is null. We are just printing not found. Otherwise, we are taking a reference temp and count 0, and we are traversing. If it is matching with the data, this loop will stop. And if it temp is null, it means what? We have reached the last node and the data is not found. Otherwise, in all other situations, we are going to print the count, that is the index at where it is found. Now for traversing the linked list, so this is what? This is forward traversing. Now do I need to change this code also? What about others? For forward traversing, do I need to change this node code? You can see temp will stop when it is pointing to null. So we all know that node is pointing to null. No. Okay. Now tell me, I want to for reverse traversing. So you have to what will be the change in this code? And just copy, and there is a one change in this code. So let me write a reverse traversing the list, and I'm using this function as public void and reverse print. Let me, okay, I'm taking the comment, just a second. Okay, so no one can tell what is the thing which we have to do. So you can see while forward traversing, let me see how many all of you are present in the class. I can see 16 students. Okay. Temp is equal to tape. Yes, Jasmeet, you are very much correct. Good job. So you can see while forward traversing, we have started from temp is equal to head. So while reverse traversing, what we have to do? We have to start from tail only. So I'm taking temp is equal to tail. Now it will stop when we reach the null. Okay, because in previous nodes also the last node is pointing to null. So it will stop when we reach till null. And what we have to do in every step, we have to update temp with what? So while forward traversing, we were doing temp is equal to temp dot next. So in reverse traversing, we will do temp is equal to temp dot previous. So this next I'm just changing with previous. So I hope that you all understood this, that this is reverse traversing. Now in our let me add this function for reverse traversing here in section case 7, that is li dot where is the reverse print, and we are having a break. So now let us see if it works fine or not. So this is okay, this is running symbol circular. Let me stop this. You have to run this level. Let me check if I have changed the object creation or not. Yes, I have changed this. So I'm running the main block. So let us insert some elements. So let us insert 1. So we have inserted 2. Let us insert 3 and 4 and 5. Now it will print what? It will print in reverse because we have inserted at front. So in front, you can see we are having 5, 4, 3, 2. Now if I press 7, it should print 2, 3, 4, 5. Yes or no? Because it will traverse from tail. So let us check if it works or not. So if I am pressing 7, yes, it is printing 2, 3, 4, 5. And now all the operations will be working in the similar manner. Okay, you can check that later. I am moving to the next operation, that is double circular linked list. So before that, let us discuss the complexity. And before discussing the complexity, just tell me if you have any confusion in this code. Just check this code. Okay, I'm scrolling from top. I'm keeping 1 minute or in every function. Just see it. Okay, everyone just see. So this is the node part. We have taken 3 variables. Okay, let me show you insert function. So see insert function, everyone. Insert at front. Any doubt? Okay, now I'm scrolling. See insert at end. Okay, take a quick look. Don't go deeper. If you found something suspicious, just tell me. Okay, now see insert after. So this is a bigger function. So take time to see this. Fine. Give me yes or no. Is it fine? If you are not replying here, I mean it is fine too. So this is delete first matching element. And this is deleting at a particular index. So here also we are just, if the position is 0, we are doing the same thing. Otherwise we are traversing till the one less element. and if any of this is null, if the temp is null or temp.next is null, we can return. It means what the element is not, the index is not found. Otherwise, we can perform these operations. Okay, so now this is searching. So searching was similar, and there is no confusion. So now let us move to the complexity part and quickly discuss the time complexity. So we have done these things. So now yes, tell me the complexity for creation. Just a second, let me check. Yes, we have done reverse traversing also. Yes. So for creation, the complexity is big of 1 and space will be big of 1. The things will be almost similar. And for insertion, it will be n. So you always n. Searching, traversing, deletion of a node, this will be n. Now deletion of linked list in some, okay, let me write here 1. So this is obvious, this should be 1. Now in some of the code, you will see that deletion of list or double linked list is big of n. So why it is big of n? So what they are doing, okay, they are going to every node and they are deallocating this previous as well as null. But in some of the codes, you can see they will just deallocate the main object as null. What I am doing, I am just deallocating the main object. So now what will happen? All that nodes will be collected by the garbage collector. So we can do it in big of 1 and space will be also big of 1. So there are many good problems. Okay, so let me show you one kind of problem. So there is a problem like you have a linked list like this. Okay, so I'm talking about single link. Just now I have realized this was a question which was asked in a company. So tell me the logic which you are going to use. Okay, so this is one linked list. This is pointing to null, and you have another linked list. Okay. So now my question to you is, yes. So these are having some values. Okay. So let us take some values like 1, 2, 3, 4, 5, 6, 7, 8, and 9. Now my question is to you is that you are given with two linked lists. We are intersecting at some point. Okay. These two linked lists we can see we are having. So if you are given with head 1, you can easily traverse that list. Yes or no? You traverse from head and you can reach. In the same, given with the second head 2, you traverse that list. Okay. So you can see in our code the functions we have created another parameter as head. And using that head we can traverse. But since we already have the class, we are not taking that head reference. But in some codes you will see you can create functions where you can accept the head. So suppose you are accepting this head and you are accepting this head. Now you have to find the data stored at the intersecting node. So you can see this is what, this is the intersecting node. Tell me what is the logic which you are going to follow. Okay, I don't need the code, just tell me the logic which you can follow. You have to give me the data of the intersecting node. This is a very interesting problem. Anyone? Are you getting? If you are not, just tell me, I will repeat.